So today we have an interesting geometrical problem. We have an isosceles triangle ABC in which AB is equals to AC. Now we take a point inside this triangle and label it as the point O and join it to all the three vertices of this triangle. Now these line segments are drawn in such a way that the angle OAB is 5 degree, the angle OBA is 30 degree and the angle OBC is 50 degree. Now the question is to find the angle OCA. So this is Anmol Mishra and now let us see the solution. How can we find the missing angle? So first of all we will mark all the required angles in this triangle, and for that we will utilize the fact that the triangle ABC is an isosceles triangle. AB equals to AC. This means angle B is equals to angle C. The value of angle B is 50 plus 30, that's 80 degree. This means that angle C is also 80 degree. Okay. Now by applying the angle sum property in this triangle ABC, we will get that angle A is equals to 20 degree. Now we can see that the complete angle A is 20 degree. Some part of it is already 5 degree. Therefore, the remaining part is going to be 20 minus 5, 15 degree. Okay, now look in this triangle OCA. Angle C is X, angle A is 15 degree. Therefore, by angle sum property, angle O is going to be equals to 180 minus 15 plus X. No need to simplify this thing, keep this as it is. And similarly in this triangle OBA, this particular angle over here is going to be 180 minus 30 plus 5, that's 35. So finally over here we have marked all the required angles. Now we will mark the side length. So let the equal side of this triangle be labeled as B. This means AB equals to AC and let it be equals to a variable B. Okay. And this length AO be equals to a variable M. Okay. So over here in this particular diagram we have marked all the required angles and all the required line segments. Now let us move on to the actual solution. So take the triangle BOA. So I'm just redrawing the triangle over here. The triangle BOA is somewhat like this. So BOA, angle B is 30 degree and angle A is 5 degree, and the measure of angle BOA is equals to 180 degree minus 35 degree by angle sum property. Okay. Now the length of BA we have taken as a variable B and the length of OA we have taken as a variable M. Okay. Now we will take our second triangle, that is the triangle COA. So the triangle COA is somewhat like this. Here is the point C, here is the point O, and this particular point is the point A. Now the angle C is X, the measure angle A is 15 degree, and the measure angle COA is equals to 180 degree minus 15 plus X by angle sum property. CA is having a length B as we have taken it as a variable, and the length of OA is equals to M. Okay. Now to move further in the solution, we will take the help of the sine rule. So what is the sine rule? Let us see that also. So the sine rule says that if you have a triangle and three of its internal angles are suppose A, B and C, and the opposite sides are capital A, capital B and capital C, then sine of A upon its opposite side, that is capital A, would be equals to sine of B upon its opposite side, that is capital B, and this thing would be equals to sine of C upon its opposite side, that is capital C. So this is the sine rule. If in a triangle all the three angles are there and its opposite side, this particular ratio would be equal. So now we are going to apply the same sine rule in our first triangle and in the second triangle. So in the first triangle, let us apply the sine rule. Therefore, sine of 30 degree, that is one of its angle, upon its opposite side, that is equals to M, would be equals to sine of 180 degree minus 35 degree upon its opposite side, that is equals to B. Now we are not going to compare the third ratio because that is not required, and it's all okay to even compare two ratios. Okay. Now let us apply the sine rule in our second triangle. Therefore, sine of X degree upon its opposite side, that is M, would be equals to sine of 180 degree minus 15 plus X upon its opposite side, that is equals to B. Okay. So now we have this and this particular ratio, and to move further we will use the trigonometric identities. So remember the rule that sine of 180 degree minus theta is equals to sine theta. So over here we have the same thing, sine of 180 degree minus 35, and over here sine of 180 degree minus 15 plus X. Therefore this ratio can also be written as sine of 30 degree upon M equals to sine of 35 degree upon B. This thing turned out to be sine 35. Similarly, in the second ratio, it can be written as sine of x upon m as it is equals to sine of 15 plus x upon b. Okay, now what I will do is a simple cross multiplication. I will take b over here and sine x over here. So over here we will have b upon m equals to sine of 15 plus x upon sine of x. So here is the first equation that we required. Now in the second ratio, that is in the yellow color, I will do again the same thing, b over there and sine 30 over here. Therefore, b upon m would be equals to sine of 35 degree upon sine of 30 degree. Keep this as the equation number 2. So this is our first equation and this is the second equation. And in both the equation, we can see that the left hand side is equal, that is b upon m. So if the left hand side of two equation is equal, we can simply compare their right hand side. So the right hand side of the first equation is sine of 35 degree upon sine 30 degree. So sine of 35 degree upon sine 30 degree equals to the right hand side of the second equation, that is sine 15 plus x upon sine x. So let us write it down over here, sine of 15 plus x upon sine x. So now what we have is a trigonometric equation to be simplified. So what I will do is, first of all, we all know the value of sine of 30 degree, that is 1 upon 2, and over here it forms sine 35 degree upon 1 upon 2, so it will form 2 times sine 35 degree, and this thing would be equals to sine of 15 plus x upon sine of x. Okay, now to simplify this thing, we have to use the master step, and that is to multiply cos of 35 degree on both of the side. So on the left hand side we will have 2 times sine of 35 degree multiplied with cos 35 degree, and this thing would be equals to sine of 15 plus x upon sine x multiplied with cos of 35 degree. Okay, now using the trigonometric identity, that is 2 times sine theta cos theta, that is 2 times sine theta cos theta equals to sine 2 theta, and if we just apply this identity over here, we will get that 2 times sine 35 degree cos 35 degree is actually sine 70 degree using this particular identity, and this thing is equals to sine of 15 plus x into cos of 35 degree, and the sine x over here in the denominator I will just multiply on the other side. So sine x into sine 70 degree is equals to sine 15 plus x into cos 35 degree. Now to simplify it further, I will multiply 2 on both of the side. So on the left hand side we will have 2 times sine x into sine 70, and this thing is equals to 2 times sine of 15 plus x into cos 35 degree. Now I will just convert cos 35 degree in sine. So we know that sine of 90 minus theta is equals to cos theta, and if I will just replace theta is equals to 35 degree, I will get that sine of 90 minus 35, that's 55, equals to cos 35. So cos 35 can be just replaced as sine of 55 degree. So over here we have again a nice equation, that is 2 times sine x into sine 70 equals to 2 times sine 15 plus x into sine 55 degree. And to simplify it further, we will use the trigonometric identity, that is 2 times sine a into sine b is equals to cos of a minus b minus cos of a plus b. It's a nice trigonometric identity, and we'll apply this identity on the left hand side also and on the right hand side also. So applying this identity on the left hand side, so we will have cos of x minus 70 degree minus cos of x plus 70. Okay, and this thing would be equals to, now again applying the identity on the right hand side, so we will have cos of 15 plus x minus 55, that is x minus 40 degree, minus cos of 15 plus x plus 55, that is 70 plus x, so cos of 70 plus x. So now we have this particular equation after we applied this particular identity in this particular equation. Okay, so now here we can see that on the left hand side we have negative cos of x plus 70, and on the right hand side we have negative cos of 70 plus x. X plus 70 and 70 plus x is same only. So these two things can be just cancel out. So what we finally have is cos of x minus 70 degree equals to cos of x minus 40 degree. So now we have this particular equation, and remember that x was some part of 80 degree in this diagram. So here is the diagram. In this we can see that the complete angle C was 80 degree and some part was only x. This completely makes the sense that x is going to be smaller than 80 degree. So over here we have this particular equation, and we have this thing that x is smaller than 80 degree. Okay, now why I am telling this, because if you have to just compare the angles of trigonometric ratio on both of the side, the angle must be in the same quadrant. So here if x is smaller than 80 degree, x minus 70 would also lie in the first quadrant and x minus 40 would also lie in the first quadrant for x smaller than 80 degree. So if you just directly compare x minus 70 equals to x minus 40, it makes no sense. This means that one of the thing is going to be negative. So over here we know this particular identity that cos of negative theta is cos theta as it is. So we can just take negative on one of these angles. So let us take that on this particular angle. Therefore cos of negative x minus 70 would be same as cos of x minus 70. So this thing will turn out to be 70 minus x. So cos of 70 minus x equals to cos of x minus 40. When we just first compare these two things, what we were getting is negative 70 equals to negative 40. And that's not true. This means that one of the angle would be negative. So over here we have just made negative this particular angle. So now 70 minus x is equals to x minus 40 degree. And if we just solve this, we will get x is equals to 55 degree. And now let us see if this x value makes this equation correct or not. So cos of 55 minus 70, that's going to be 15 degree. So negative 15 degree and equals to cos of 55 minus 40, that is 15 degree. And this is actually the identity that cos of negative theta is cos of that theta only. This means x is equals to 55 is the answer that we were looking for. So this was my way to solve this particular question. If you have any other method other than this, you can do comment below, and if it's hard to comment, you can email me or else you can send it to me on my Instagram. The link is in the description.